Recall from the previous video the definition of the absolute value of a number. We said that when the absolute value of x is less than some number a, this means that x is less than a units away from 0. Alternatively, when we say that the absolute value of x is greater than some number a, this means that x is more than a units from 0. We're going to use these definitions to solve some absolute value inequalities. Let's look at our first example here. We have that the absolute value of the quantity 5x minus 4, all divided by 3, is greater than or equal to 5 over 9. This means that the quantity 5x minus 4 over 3 is at least 5 over 9 units away from 0. Let's just take a look at the number line and try to visualize how we're going to set up our equations. Here is 0, here is positive 5 over 9, and here is negative 5 over 9. The quantity 5x minus 4 over 3 could be at either one of these two locations because this is a weak inequality, but it also could be further than 5 over 9 units away from 0. So it could be to the left of that as well, or to the right of the second number. As inequalities, we can say that 5x minus 4 all divided by 3 is either less than or equal to negative 5 over 9, or that the quantity 5x minus 4 all over 3 is greater than or equal to positive 5 over 9. Remember that saying that an absolute value is at least some number means that we are traveling away from 0. Now we just have to solve these two inequalities to finish finding the solution to this problem. So in the first inequality, we can multiply both sides by 9 to eliminate the two denominators. So if we multiply both sides by 9, then we have 9 times 5x minus 4 over 3 is less than or equal to 9 times negative 5 over 9. And this simplifies to 3 times 5x minus 4 is less than or equal to negative 5. The 3 came from the fact that 9 divided by 3 is 3. By distributing, we get 15x minus 12 is less than or equal to negative 5. If we add positive 12 to both sides, we get that 15x is less than or equal to 7, or that x is less than or equal to 7 over 15. Solving the second part of the inequality, again, multiplying both sides by 9 to clear those fractions, we get 9 times 5x minus 4 over 3 is greater than or equal to 9 times 5 over 9. And this simplifies to 3 times 5x minus 4 is greater than or equal to positive 5, or 15x minus 12 is greater than or equal to 5. If we add 12 to both sides, we get that 15x is greater than or equal to 17. Dividing both sides by 15, we get that x is greater than or equal to 17 over 5. Now we can write this in interval notation. For the first part of the interval, we don't have a lower limit, so we'll go from negative infinity up to and including 7 over 15. And for the second part of the interval, we have 17 over 5 as our included lower limit, and we have no upper limit, so we'll travel in the direction of positive infinity. And then we'll use the union symbol, which looks like a capital U, between these two disjoint intervals to show that the solution contains all of the values that appear in either one of these intervals. Now, let's look at what is different with the next problem. We have the absolute value of 2x plus 1 is less than or equal to 11. Here, the distance from 0 is 11 or less. So again, I like visualizing the work with the number line. We'll say that 0 is there. Here's positive 11, and here's negative 11. It could be that the quantity 2x plus 1 is at negative 11 or at positive 11 because this is a weak inequality. The distance could be exactly 11 from 0. But it also could be that 2x plus 1 is somewhere closer to 0 from those 2 points. So in fact, 2x plus 1 could be anywhere in the shaded region, including both negative 11 and positive 11. So we can write this as a three-part inequality and say that the quantity 2x plus 1 is either greater than or equal to negative 11 or less than or equal to positive 11. In other words, the quantity 2x plus 1 is somewhere between these two numbers or at one of the two numbers itself. Let's solve the three-part inequality by isolating x in the middle portion. First, we subtract 1 from all three parts. Negative 11 minus 1 is negative 12. In the middle, 2x plus 1 minus 1 gives us 2x. And on the right, 11 minus 1 will give us 10. Now, we divide all three parts by positive 2 because we're dividing by a positive number. We don't have to worry about the direction of the inequality symbols changing. They will stay the same. Negative 12 divided by 2 is negative 6. 2x divided by 2 is x. And then 10 divided by 2 is 5. Writing this as a three-part inequality says that x is sandwiched somewhere between these two numbers, but let's write this in interval notation. X is between negative 6 and 5 inclusively, right? It could be exactly negative 6. It could be exactly positive 5. So we will include both of those numbers in our interval.